Hello, everyone, and welcome to the AI for Performance Engineers series. Let me start by asking you a simple question. Imagine you have just been assigned to a new API performance testing project. The client shares the business requirements, API documentation, and a deadline that's much closer than you would like. Before you have even started building the test scripts, you are expected to understand the application, identify performance risks, prepare a test plan, design the workload model, and eventually deliver a professional performance report. Now ask yourself, what if you had an intelligent assistant that could help you complete many of these tasks faster? That's exactly why artificial intelligence has become such an important topic in today's software industry. But here is the question that many performance engineers are asking. Can AI replace performance engineers? That's the question we are going to answer in today's episode. Before we continue, I would like to set the right expectations for this series. This is not an AI course where we will learn machine learning concepts. This is not a prompt engineering course. And this is not another Apache JMeter tutorial. Instead, this is a project based performance engineering series. Over the next 8 episodes, we'll work on a realistic API performance testing project from start to finish. We will use free local AI tools to assist us throughout the project, from reviewing requirements and creating engineering documents to building JMeter API scripts, analyzing performance results, and preparing a client ready performance test report. The objective isn't to prove whether AI is good or bad. It's to understand how experienced performance engineers can use AI to improve productivity while continuing to make the engineering decisions that matter. So, before we begin building our project, let's first understand why AI matters for performance engineers and whether it's truly changing our profession or simply changing the way we work. Let's get started. In the previous slide, we asked an important question. Can AI replace performance engineers? Before we answer that, we first need to understand why AI has become so relevant in performance engineering. Let's take a step back and look at how software applications have evolved. A decade ago, many enterprise applications were relatively simple. Most were monolithic applications connected to a single database with fewer integration points and predictable user traffic. Performance testing primarily focused on measuring response time, throughput, and server resource utilization during that time. But today, the landscape is completely different. Modern applications are built using REST APIs, microservices, containers, Kubernetes, cloud native platforms, distributed databases, and third party integrations. A single user request may travel through multiple services before a response is returned. As these systems has become more distributed, the amount of information that the performance engineers need to understand has increased significantly. Before we even execute a performance test, we often need to review business requirements, API documentation, architecture diagrams, authentication mechanism, workload expectations, and performance requirements. And after execution, we need to analyze the reports, logs, metrics, dashboards, and traces to understand the system behavior. The challenge today isn't a lack of engineering knowledge. The challenge is the volume of information that needs to be processed within the tight timelines. This is exactly where AI becomes valuable. What AI can do is AI can quickly summarize documentation, organize technical information, identify the patterns, and help us to process a large amount of data in a fraction of time it would take manually. This does not eliminate the need of performance engineers. Instead, it allows us to spend less time on gathering information and more time analyzing it, solving problems, and making better engineering decisions. So, the reason AI matters today is simple. Software systems have become more complex, and AI helps us manage that complexity more efficiently. Now that we have understand why AI has become important, let's address one of the biggest misconceptions in the industry by separating AI myths from engineering reality. Now that we have understand why AI has become important, let's address one of the biggest question in the industry. There are many opinions about AI. Some people believe it's going to replace software engineers and testers. Others think it can solve even every technical problem with a single prompt. The reality is somewhere in between. Let's look at a few common myths. The first myth is that AI will replace performance engineers. In reality, AI is a tool that enhances the productivity. It can gather ideas, summarize information, and automate repetitive tasks. But it does not understand clients' business objectives, production environment, or project constraints the way an experienced engineer does. The second myth is AI always provides the correct answers. AI generates responses based on the information it has learned and the context that we provided. While many of its suggestions are useful, they are not guaranteed to be accurate. Sometimes AI may misunderstand a requirement, make assumptions, or miss important project specification details. The third myth is AI automatically understands every project. AI only knows what we tell it. If the requirements are incomplete, the API documentation is outdated, or the prompt lacks context, the quality of the response will be also affected. In simple terms, better inputs usually lead to better outputs. Finally, some people believe that using AI reduces the need for technical expertise. In my expertise, the opposite is true. The engineers who benefit the most from AI are usually the ones who already understand performance engineering fundamentals. They know what questions to ask, what information to provide, and how to evaluate whether the AI response is technically correct. So instead of thinking about AI as something that replaces engineers, it's more powerful to think or useful to think that it is a productive tool that helps us more in terms of our work to make it more effectively. So understanding these realities gives us the right mindset for the rest of this course. Because from the next slide onwards, we'll shift our focus from what AI can do to what only a performance engineer can do. So far, we have answered two important questions. First, we understood why AI has become increasingly important in performance engineering. Second, we separated some of the common myths from reality. Now, let's look at something even more important. Where does human expertise make the difference? To answer that, let's imagine a real project. A client asks us to certify that their application is ready for production. They want to know whether the system can handle the expected workload and whether there are any performance risks before the go live. AI can certainly help us or help you along the way. It can review the documents, it can summarize the API specifications, and it can generate the initial test plans, suggest a workload model, and even creates a basic JMeter scripts. But can AI confidently tells the client, yes, your application is ready for production? The answer is no. That decision requires much more than generating information. As a performance engineer, you need to understand the business critical user journeys, identify realistic workload patterns, verify that the test scenarios represent actual production traffic, interpret performance metrics in the right context, and evaluate whether the observed results meets the client's performance objectives. Sometimes two applications can show exactly the same response time, yet one is considered acceptable while the other is not. The difference lies in the business context, not the numbers alone. Similarly, if you observe an increase in response time during a test, AI might identify the trend, but determining whether the issue is caused by the application, the database, the infrastructure, the network, or any other external dependency requires investigation, technical knowledge, and experience. This is where performance engineers create real value. We do not just collect data, we interpret it, ask the right questions, evaluate the risks, and provide recommendations that organizations can trust. Throughout this series, you will notice a consistent pattern. We will use AI to reduce the repetitive work and accelerate project activities, but every important deliverable will be reviewed and refined using engineering expertise before it becomes a part of the final solution. That's the mindset we'll carry into every practical exercise in this course. In the next slide, we will see exactly where AI fits into the complete performance engineering lifecycle and how it supports us at each stage of a real client engagement. So far, we have answered four important questions. We now understand why AI has become important. We have separated myths from reality, and we have seen where human expertise remains essential. The next logical question is, where can AI actually help during a performance engineering project? The answer is throughout almost the entire performance testing project lifecycle. Let's walk through a typical API performance testing engagement. Every project begins with understanding the client's requirements. We review business documents, we review API specifications, architecture diagrams, and performance expectations. Instead of manually reading hundreds of pages, AI can quickly summarize the information, highlights important APIs, and even identify areas that may require further clarification. Once we understand the project, the next step is to prepare the performance test plan. AI can generate a well structured first draft based on the inputs we provide, helping us save time on documentation and allowing us to focus on refining the strategy. After that, we design the workload model. AI can suggest user distribution, think time, and workload percentages based on the available business information. As engineers, we validate those recommendations to ensure they represent realistic production traffic. Next comes the script development. AI can assist in generating an initial Apache JMeter API test script, including request structures, headers, basic parameterization, and assertions. This gives us a strong point or strong starting point, but we still verify the request flow, authentication, correlation, and overall script quality before execution. Once the tests are executed, AI can help us to analyze the HTML report by identifying the trends in response time, throughput, error percentage, and percentile metrics. This allows us to focus our attention on the areas that need a deeper investigation. Finally, when it's time to prepare the performance test report, AI can organize the findings into a professional document, helping us to create a clear and structured report for stakeholders. If you look carefully at every stage, you will notice a common pattern. AI helps us complete engineering activities faster while we ensure that every deliverable is accurate, meaningful, and aligned with the project objectives. And that's exactly how this course is structured. Each of the remaining episodes focuses on on these particular stages, and by the end of this series, we will have a completed full API performance testing engagement, from understanding the requirements to delivering a client-ready performance report. Now that you have seen the complete engineering lifecycle, let's introduce the real world project that we will build together throughout this entire series. Now that we have seen where AI fits into the performance engineering lifecycle, it's time to introduce the project that we will work on throughout this series. Instead of using small disconnected examples in each episode, we'll work on one continuous real world project. This approach will will help you to understand how all the deliverables are connected in an actual performance engineering engagement. Here is the scenario. Imagine you're working as a performance engineer in your organization. A client has developed a new e-commerce REST API application and it's scheduled to go live in the next few weeks. Before the production release, the client wants to ensure that application can handle the user traffic and deliver a reliable user experience. To begin the engagement, the client has shared two important artifacts with us. The first is the business requirement document, which explains how the application works, the key business processes, and the expected user behavior. The second is the Swagger or API documentation, which provides the technical details of the REST APIs that we will be testing. As the assigned performance engineer, our responsibility is to take these inputs and complete the entire performance testing engagement from planning to final reporting. We'll begin by understanding the requirements, then we'll prepare the performance test plan, design the workload model, build the JMeter script, execute the performance test, analyze the results, and finally deliver a professional performance test report to the client. What's the different in this series is that we'll use AI as our engineering assistant throughout this particular journey. We'll use it to accelerate the documentation, generate initial drafts, assist in scripting, and help analyze performance results. But very important decision, every important decision and every final deliverable will be reviewed by us before it's considered complete. By following the same project across all the 8 episodes, you will not only learn how to use AI effectively, but also understand how a real API performance testing engagement progress from the first client meeting to the final project delivery. In the next slide, before we begin the practical work in the future episodes, let's clearly define the scope of this series, like what we will cover and what we'll intentionally keep for future advanced courses. Before we move forward, I would like to clearly define the scope of this series so you know exactly what you will learn. One of the biggest challenges with the online courses is that learners often expect them to cover everything. As a result, they end up learning many topics superficially instead of mastering one practical skill. That's not the approach we'll take here. This series has one clear objective: to complete the real world API performance testing project using free local AI tools. Throughout this journey, we will use Ollama, the Qwen language model, Visual Studio Code, and Apache JMeter to solve real engineering problems that performance engineers encounter during a client engagement. We will learn how to review the documents, prepare engineering documents, and design workload models, build test scripts, and generate professional client reports, all with AI assisting us at each and every stage. However, it is equally important that to understand what this series is not designed to cover. We won't be focusing on the browser web-based performance testing, advanced JMeter scripting techniques, enterprise automation frameworks, distributed load generation, or cloud-based load testing, observability platforms, or performance tuning. These are all the valuable topics, but each deserves dedicated attention and practical demonstration of its own. My goal is not to overwhelm you with too many technologies in a single series. Instead, I want you to build a strong foundation by mastering one complete API performance testing workflow. Once you understand this, the end-to-end process learning advanced topics become much easier because you will already have the right engineering mindset and project experience. Think of this series as the foundation of a larger learning journey. Master this project first, and you will be well prepared to explore advanced performance engineering topics in the future courses. Now that we have defined the scope, let's look at how the next 8 episodes fit together and how each one contributes to the final project deliverable. Now that you have understand the scope of this series, let's look at the complete roadmap and see how every episode contributes to a single performance engineering project. One of the biggest advantage of this course is that the episodes are not independent tutorials. Instead, each episode builds on the output of the previous one, just like a real client engagement. Let's walk through the journey. In episode 1, we are building the foundation. We have discussed why AI is becoming an important part of the modern performance engineering, where it adds value, and how we will use it responsibly throughout this series. In episode 2, we will set up our complete local AI environment. We will install Ollama, download the Qwen language model, configure Visual Studio Code, and create the project workspace that we will use for the rest of the course. With our environment ready, we will use or we'll move forward to the episode 3, where we will review the client's business requirements and Swagger documentation. Our objective will be to understand the application, identify performance related requirements, highlight missing information, and document potential risks before any performance testing begins. In episode 4, we will use those findings to create a professional API performance test plan, defining the project objectives, scope, assumptions, risks, and deliverables. Once the test plan is finalized, we will proceed to the episode 5, where we will design a realistic workload model. We will define or will determine API distribution, concurrent users, think time, and workload patterns that closely represents the real production usage. With the workload model complete, Episode 6 focuses on building the Apache JMeter API test script, where we will use AI to accelerate script creation while validating the requests, authentication, parameterization, correlation, and assertions before execution. In episode 7, we will execute the performance test and analyze the JMeter HTML report. We will interpret key metrics such as response times, throughput, error percentage, and percentiles to identify performance symptoms and understand what the results are telling us. Finally, in episode 8, we'll bring everything together by preparing a professional performance test report. We'll summarize the testing activities, documents the findings, highlight the risks, and present the recommendations that helps the client to make informed business decisions. By the end of these 8 episodes, you'll have a complete you'll have completed the same sequence of activities that a performance engineer typically performs in a real project. Instead of learning isolated concepts, you will understand how every deliverable connects to the next, creating a complete end-to-end performance engineering workflow. In the next slide, let's look at the practical skills and outcomes you will gain by completing this journey. We have now reached the final part of this introduction. And before we conclude, I would like to answer one important question. What will you actually gain by completing this particular series? By the end of these 8 episodes, you won't just know how to use an AI tool, you will know how to apply AI in real performance engineering project. You will be able to set up your local AI environment using free tools, understand the client requirements, prepare the professional engineering documents, build API performance tests, especially test scripts in Apache JMeter. You can also learn analyzing the test results with confidence and create client ready performance test reports. More importantly, you will develop a structured approach to performance engineering. Instead of wondering what to do next after receiving a new project, you will have a repeatable workflow from understanding the requirements to delivering the final report. Another important outcome is that you will learn how to work with AI, not depending on it. Throughout the series, you will see a practical example of using AI to accelerate routine tasks such as reviewing documentation, generating initial drafts, organizing the information, and assisting with analysis. At the same time, you will also learn when to question AI's recommendations and how to refine them using engineering knowledge and project context. These are practical skills that you can immediately apply in your day to day work, whether you are working on a small API performance testing assignment or a large enterprise project. My goal is that after completing this series, you will not only become more productive but also more confident in handling performance engineering engagements from start to finish. And that's exactly what we will build together over the next 8 episodes. In the final slide, I'll summarize the key message from today's session and give you a preview of what we are going to build in the episode 2. We have now reached the end of the first episode. And before we conclude, let's quickly recap what we have learned today. We started by understanding why artificial intelligence has become increasingly relevant in modern performance engineering. As software systems continue to evolve, performance engineers are expected to analyze more information, work across multiple technologies or more technologies, and deliver results within shorter timelines. We then separated common misconceptions from reality and discuss the role AI can realistically play in our profession. Instead of reviewing AI as a replacement, we looked it as a productive tool that helps us work more efficiently throughout a performance engineering project. Next, we explored the complete performance engineering lifecycle and saw how AI can assist us from reviewing requirements to preparing the final performance test report. After that, I introduced the real world e commerce API project that we will build together across this series. Rather than learning isolated concepts, we'll complete a continuous project where every episode produces a meaningful engineering deliverable. We also defined the scope of this course and reviewed the complete 8 episode roadmap. So you know how, you now have a clear picture of what lies ahead. By the end of this series, you will have a practical understanding of how to integrate AI into an API performance testing workflow while producing deliverables that are relevant to real client engagements. Now it's time to move from concepts to implementation. In the next episode, we'll build our complete local AI environment from scratch. We'll install Ollama, download and run the Qwen model, and configure the Visual Studio code. We'll also create our project workspace and verify that everything is working correctly. Once our environment is ready, we'll use it throughout the remaining episodes as we build our complete API performance testing project. Thank you for watching this first episode. I hope it has given you a clear understanding of what this series is about and what we will accomplish together. I'll see you in episode 2, where we will begin our hands on journey by building our local AI assistant.